Hi, my name is Jiashu Xing, and I'm a Tencent Cloud Database Senior Engineer. The work I'm presenting today is our new service, CDBTune, Intelligent Knobs Tuning Service. Database is a key component of many applications. Obviously, performance is a key point. Besides circle optimization and index optimization, knobs tuning is vital to optimize the performance of a database. So, why do we need knobs tuning service? We have some problems here. First, database has many knobs, in practice hundreds maybe. It's hard to do knobs tuning. Second, it's time consuming even for experienced DBA. Third, we don't have many available tools now. And finally, we have diverse cloud databases and workloads, which make the requirements of knobs tuning strong and urgent. So we developed CDBTune, Intelligent Knobs Tuning Service for cloud databases. It takes an end-to-end model to tune knobs according to users' workload. And how can we do this? We desire to design an efficient end-to-end tuning system. At the same time, we hope that our model can learn well with limited samples in the initial training and simulate the DBA's tuning experience as much as possible. Therefore, we try the reinforcement learning method. The learning process is summarized as follows. The state metrics keep the statistic information of the CDB, which describe the current state of the database, and are called internal metrics. When tuning CDB upon a tuning request, we will collect and process the metrics data which can capture more aspects of CDB runtime behavior in a certain time interval. As for external metrics, we take samples from latency and throughput data. Database is the target that we need to tune, which can be regarded as the environment in reinforcement learning, while the deep reinforcement learning model in CDBTune is considered to be the agent in reinforcement learning, which is mainly composed of a deep neural network, whose input is the database state and output is the recommended knobs corresponding to the state. When executing the recommended knobs on CDB, the current state of the database will change, which is reflected in the metrics. Metrics can be used to evaluate the performance of a database for calculating the responding feedback reward in reinforcement learning. Agent will update its network according to these two feedback information to recommend knobs. This process iterates until the model converges. And finally, we get the most appropriate knob settings. However, we still have problems to be solved. First, reinforcement learning has cold start problem and resulting performance fluctuation. It takes hundreds of steps to find optimal knobs for TPCC test. Second, tuning time is important for online service. The target time should be acceptable for user experience, but typically, reinforcement learning results in long tuning time. Besides, we want to reduce knobs tuned and get most valuable top key knobs. To accommodate these problems, we propose a hybrid model. The key feature of this model is a hybrid architecture, which uses samples generated by genetic algorithm to warm start the finer-grained exploration of deep reinforcement learning. Meanwhile, we employ principal component analysis, random forest, and fast exploration strategy to reduce the search space and update time of the learning model. In addition, we further propose a clone and parallelization schema to stress test workloads on multiple cloned CDB instances in parallel, resulting in faster and safer node exploration. The main workflow is summarized as follows. First, the actor interacts with the database clone from user's instance. Actors are designed to run workload, collect runtime metrics, and manage parallel execution on clone database. Second, the hybrid tuning system consists of a shared pool of sampled nodes, interacting with three components. Sample factory, which generates samples according to target workloads and users' requirements via GA and rules. Search space optimizer, which takes as input the samples generated by the sample factory and conduct compression and dimension reduction over both matrix and search space. Recommender, which use reinforcement learning to further explore the search space when started using the shared pool of samples. A request from a user consists of a CDB instance, workload information characterized as a set of queries, a personalized requirements, a time budget, and the maximal degree of parallelization. Given this request, the controller allocates a set of actors, each of which first clones the user's instance. Each actor can also use the input workload information to stress test all cloned CDBs that it allocated. In the first phase, each actor generates random nodes and stress tests them on cloned CDBs. Each stress testing generates a sample, which is put into the shared pool. Sample factory takes as input these randomly generated samples and uses genetic algorithm to generate new nodes. The controller then stress tests these newly generated nodes and produces new samples in the shared pool. In the second phase, the search space optimizer collects statistics using all samples in the shared pool and conducts compression and sifting over metrics and nodes. In the third phase, recommender using DDPG acts over samples with reduced dimension and generates new nodes. One key design decision is to warm start the recommender using all samples in the shared pool. This allows us to take advantage of the massively parallelizable nature to warm start the powerful, finer-grained exploration process enabled by deep reinforcement learning. So in conclusion, we propose an online tuning system to improve the performance as well as efficiency and practicability on CDB. We tackle the availability problem by tuning and testing knobs on cloned CDBs. We tackle the cold start problem with a hybrid architecture, in which we use the samples generated by GA to warm up DDPG. Based on the cloned CDBs, we design a parallel schema for DRL, making DDPG practical for the on-the-fly Xing with the fast velocity of exploration. We use random forest to sort top key knobs. In addition, we use fast exploration strategies to speed up reinforcement learning, which forces the model to explore based on relatively better nodes. Let's talk about physical implementation. CDBTune service is the scheduling service. It schedules tasks, do health check, and recover field task. CDBTune worker is a work node. It runs actor and learner task. Actor task interacts with databases, set nodes, and run workload. Learner task runs DDPG and genetic algorithm. It recommends knobs for active tasks. Left picture shows a typical workflow. User's request is sent to CDBTune service. CDBTune service dispatches tasks to CDBTune worker. Works run parallel active tasks, set knobs, and run workloads. Then it reports samples and fetch recommendations knobs. Learner tasks fetch samples and learn. It recommends knobs and save network. We use audit plugin in cloud database to capture workload and record it in time series database. As shown in picture, circle and transaction are recorded. We can replay them to replay user's workload, but that is not enough. In knobs tuning, we also want to stress test database with high concurrency and throughput. So, we designed a new workload generator tool. First, the user's workload is split into sub-workload according to time series data. Second, we use histogram to provide data distribution information. Third, we abstract circle sequence pattern and transaction template to simulate access patterns. Besides, transaction dependency and transaction conflicts is also considered. And finally, we can use the information above to generate similar workload and replay or stress test database for knobs tuning service. Our service is available now on Tencent Cloud databases. In Parameter Configuration tab, you can select Workload Tuning. Only standard workload is available. You can select workload and corresponding options, for example, read-write ratio, concurrency, date size, etc. Then submit task. After task finishes, knobs tuning session is available. The session shows knobs value and whether need to restart database. Then you can apply knobs to database right now or during maintenance hour. We are developing workload generator tools to generate similar workload from users' workload. It will be available in several months. Thank you.